Alright guys, we're going to go ahead and pick up with example 2. Here, this quadratic equation has an important couple pieces of information. One is we can get the x value of your vertex with this formula, h equals negative b over 2a. That's going to be useful because this, using the methods that we're going to practice in example 2, makes it where you don't have to complete the square or factor. So that might be helpful to some of you. This is a different method that we're going to look at with example 2. You guys remember this is our vertex form. Okay, so A is controlling the width and whether it's right side up for a positive A, upside down for a negative A. Remember the H is shifting left and right, and the K on the outside is shifting up and down. Okay, so just remember those few pieces of information. So H and K are going to be useful. Okay, so the vertex here is given, the vertex formula is given here. And so again, we're not going to have to complete the square this time. We're going to use this for the x value of our vertex, and then we're going to take that value and we're going to evaluate the function at that value for the y coordinate of the vertex. Okay, so the vertical line, which is the axis of symmetry, is going to be x equals the x value of our vertex. Okay, I've already talked about this. A is positive, it opens upward. If A is negative, the parabola opens downward. Okay, so here example 2 says, without graphing, locate the vertex and axis of symmetry of the parabola and decide whether it opens up or down. Okay, now we can go ahead, let's go ahead and say, well, I know that it opens down. It opens down, you can circle it or write out it opens down, because A is equal to negative 2, and negative 2 is less than 0. So since A is negative, it's going to be opening down. It's going to be upside down parabola. Okay? But let's go ahead and let's look. Our A value in this standard form is negative 2. Our B value in this form is easy to detect. It's positive 8. And our C value is negative 3. Okay, so these are three important values. So we're going to look at our vertex formula, and we're going to get the x value of our vertex. So the x value of our vertex, so x coordinate of vertex. All right, the x coordinate of our vertex. So we're going to use our formula here. We have h, which is the x value of our vertex, is equal to negative b over 2a. All right, so we have negative b, negative 8 over 2 times negative 2. Okay, so that means we have negative 8 over negative 4, which means the x value of our vertex, negative 8 over negative 2, the x value of our vertex is 2. Okay, so that's the x coordinate of our vertex. The y coordinate of our vertex is for us to take the function here, f of x, and evaluate the function at the x value of our vertex. We're going to evaluate this function at positive 2, okay? And so when we evaluate the function at positive 2, we get negative 2 times 2 squared. So I'm just plugging in 2 for every x in the function. All right, plus 8 times 2 is minus 3. Minus 3. Sorry about that. Okay, and so we have negative 2 times 4. 2 squared is 4, plus 16 minus 3. Okay, so let's keep going with that a little bit. So we have that is equal to negative 8 plus 16 minus 3. Okay, so negative 8 plus 16 is positive 8, minus 3 is 5. So that means that the vertex of this thing, the vertex is at 2, the x coordinate, 5 for the y coordinate. Okay, So I don't have to graph this. I can see that my maximum, the tip-top point, the vertex, is 2, 5. Okay? Let's see what else we were asked for. We were also asked, okay, locate the vertex. Oh, axis of symmetry. So once we have the vertex, we just take the x value of our vertex. So our axis of symmetry, alright, axis of symmetry, I'm abbreviating symmetry, is x equals 2. So that'd be a vertical line going through the x-axis at 2. It also would go through the vertex because that's the x-coordinate of our vertex. Okay, so I think we answered everything we're supposed to. We've got our axis of symmetry. Okay, we've got our vertex. Alright, and we have whether it opens up or down. And again, it opened downward because of the negative a value. Okay, so that's example 2. Alright, let's move on to this example 3. I think I can finish, there's a time limit of 15 minutes on these videos, so I think I can finish up example 3 in this video and then finish up the notes with example 4 in a final video today. Okay, so this is something that you haven't done since Algebra 2. We're going to calculate the discriminant, and there's a summary of the discriminant here. Number 1 says if the discriminant is positive, it has 2 x-intercepts. If the discriminant is 0, it has 1 x-intercept. And if the discriminant is negative, it doesn't have any x-intercept. It doesn't touch the x-axis. Okay, so we've got that example here, and it gives us the discriminant expression b squared minus 4ac. Okay, so we're going to look at that. So for example 3, it says how to graph a quadratic function by hand using its properties. So here's yet another method. Okay, the first thing that we're going to do, it says determine the domain of the range, determine where it's increasing and decreasing, graph it using its properties. Okay, first off, the first thing that I'm going to point out here is that I know that this is opening downward, okay? And the reason I know that it opens downward is because of this a value of negative 2. So it opens down because a is equal to negative 2, which is less than 0, okay? So that's one property that we can go ahead and look at. Okay, the second thing I want to do is I want to calculate this vertex, okay? So this function's vertex. So let's go ahead and do that. So for our vertex, we want the x-coordinate. Vertex x-coordinate. So I'm going to take and find h. Alright, so h is equal to negative b over 2a. Alright, so let me scroll back up right here. So I have negative b, so negative 4, that's the b value, over 2 times the a value is negative 2. Okay, so I have negative 4 on top is equal, over 2 times negative 2 is negative 4, that's equal to 1. So that x value of our vertex is positive 1. Okay, now we're going to evaluate the function at that x value. That's so we can find the k value or the y value of our vertex. So the y coordinate is going to be the function f of x evaluated when x is 1. So that means we're going to plug in a 1 for every x of this function. So I'm going to put negative 2 times 1 squared plus 4x, 4 times 1 plus 2. Okay, so negative 2 times 1 squared plus 4 times 1 plus 2. Okay, just making sure I did that right. Alright, looks good. So I have negative 2 times 1 plus 4 times 1 is 4 plus 2. Okay, so negative 2 times 1 is just negative 2 plus 4 is positive 2 plus 2 is equal to 4. Okay, so that means that our vertex is 1, 4. Okay, 1, 4 is our vertex. It opens down because we have a negative leading coefficient. So that vertex is a absolute maximum. Okay. The next property that we're going to look at, we know that it has an axis of symmetry. So our axis of symmetry alright, that's going to be x equals 1. So that's the x value of our vertex. Okay. Next thing we're going to look at is, let's go ahead and get a y-intercept. Okay, now remember, for a y-intercept we're going to replace x with 0. Okay, and then we'll be able to find what our y is. So I'm going to evaluate the function when x is 0. So I'm going to get negative 2 times 0 squared plus 4 times 0. Let's see, plus 2. Okay, so I have 0 plus 0 plus 2. Alright, so the y-intercept is 2. So y-intercept is 0, 2. Okay, y-intercept is 2. Alright, so there's another important piece of information. Okay, I'm going to get you started with the last piece, and we'll go until we've got time. So the last piece is going to take a little bit, because we're going to review something that you haven't done in a while, and that's, we're going to find the discriminant. Okay, now the discriminant is just before this example in your notes. Okay, so like I said, we can calculate the discriminant to decide what type of solutions we have. So the discriminant expression is b squared minus 4ac. So this is the expression that's under the radical in the quadratic formula, which we'll look at in a little bit. Okay, so the b value is 4. This is b from our just original expression. So I'll write these here again. A is negative 2, b is 4, and c is 2. Okay, so that's just the coefficients and constant. Alright, so the discriminant is going to be 4 squared minus 4 times negative 2 times c, which is 2. Okay, so we've got 16 minus 4 times negative 2 is negative 8. Okay, and we have a 2 here that we're also multiplying. Oh. Okay. Alright, so I have 16, then I have minus negative 8 times 2 is negative 16. So really I have 16 minus negative 16, which is 16 plus 16. So my discriminant is 32. Alright, so since my discriminant is a positive number, so discriminant is a positive number, that means I have 2 real solutions, okay, which is the same thing as saying I have 2 x-intercepts. Okay, so I know I have 2 x-intercepts. Alright, so the last thing is we need to find specifically what are those x-intercept values. Okay, that we're going to pick up with that on our final video. So this is video 3AB, and the final video will be 3AC. Okay, so we'll pick up with the last video to finish out the notes. We're going to finish up example 3, and then we're going to do example 4 and be all done.